Hi, my name is François Normandin, and this is a tutorial on getting started with a unit test for Caraya version 1.0. So in this demo, I'm gonna take a small project, very simple with one method, and here it is. One method that is a function that I'm gonna want to write some code and make a test. And so the code has not been written, and I can see in the description that the architect for the project told me that, okay, this method will coerce the input values between the interval of 0 and 1 and return true if the input value is within 0.3 and 0.8 interval. And so I've got a bunch of little requirements here in words. So I'm going to do the coding for that. And I've already prepared a unit test because we want to test that function. Right now it's broken because the method is not wired, and I've got some test requirements that are very simple. So my test name is going to be interval testing, and I've got 5 requirements here that I'm gonna make sure that are tested before we finish. So we're going to use Caraya to do that and produce a small report at the same time. So here it is. Let me just wire up quickly. This VI, so we want to have between 0 and 1. All right, and I'm gonna make sure that I've got some bugs here, just so that we can see that the unit test will obviously catch it. That's the whole point, right? So between 0.3 and 0.8, and you've already assumed, if you check that, well, I've got a problem. First off, the upper limit is not taken into account. I'm going to say, okay, I include the upper limit, so now this is going to be fine, but I'm going to forget about that upper limit, and in range should be, right, all right, it's not in range, but it's been coerced 2.3, so that's obviously not what I want as well. I will want to have the output coerced to 0. So I've got 2 bugs right now, right? Because if I put 0.8, it's not in range, but the requirement says that it should be. All right, so I've got 2 bugs, and I'm going to catch that with some smart unit test. Okay, so first, let's find our Caraya palette. So it's installed in the JKI toolkits, Caraya Unit Test Framework, and I'm going to pin that right here to be reused, but you can also use Quick Drop plugin, where if you don't know, control space, and define test. So I've got define test suite. I want to have the define test. And for every VI that is a test that contains assertion, I'm basically registering the test itself with the framework by calling define test. So as per requirements, I will name that interval testing. Now every assert that happens after the define test will be recorded with the framework. If you were to have an assertion that is not sequentially bound to the define test, LabVIEW, because of the data flow nature of it, might execute this node before defining the test, and therefore you will lose your assertion. So don't do that. Always wire your error wires. Okay. So here I'm going to do just a quick one. The first one, which will be, let's say, just so that we're all on the same page, and then we can go through all these requirements together. So first off, there's an assert polymorphic VI. Also, if you do assert in Quick Drop plugin, that's the polymorphic instance that will show up as the first iteration. Now you could also go and say assert error, for example, and you see it's not the polymorphic one, but it's much simpler if you just go here. Boom, that's the same thing. All right, so please use a Quick Drop, or if you don't, then at least just take the polymorphic instance, right? Okay, Caraya. If I assert something that doesn't work, like false for assert true, it's going to throw an error here, and the framework is going to register that as a failure. I'm also going to add a label For now, let's say the label is empty or it's not wired. What should happen? Right, this is broken. Good. Control R to run your VI, and the framework caught that there's a test defined, there's an assertion, so it reports, it's here, assert true, didn't work. Now, why is it saying assert true? That's not very useful. That's because our label is empty. So now if I were to put, let's say, first test, okay, and run it again, boom, suddenly it's test. Nice feature of Caraya, double click on the failure, and you're gonna go back straight to your test. Awesome. Okay, so we've named it test just to demonstrate. Okay, double click, it goes straight to the node that failed. Now we're gonna go and start populating our test requirements. Now don't forget here, this node will fail because we've left it with two different problems. So we're gonna pretend that we are not the ones responsible for doing the coding, or we're just producing the test. We know that there was a test method. That test method, maybe it's finalized, maybe it's not, maybe it's got bugs. We're gonna find out. Okay, let's pretend we don't know about it. So first off, test all the values between 0 and 0.29 by increment of 0.1. Okay, what happens if I were to, let me do something very quick here. Okay. I have some helper VIs. Yeah, let's forget about them for now. Good. Okay. So this is going to produce an array from 0 to 0.29. It's just an array with an increment of 0.01. So it's going to produce a lot of values. And what I'd like to show you first is, what if I were to run that into a loop? Now this is perfectly legit. The only problem with that is that we're going to have 30 assertions all called the same thing, test. And yeah, that's not very useful. Now, you might see that there are two different icons. The first one failed and all the others show as errors. So errors means that there was an incoming, a downstream error, and it just skipped the test. All right, so that's useful if your test takes a second, for say, because it's doing heavy computation. Well, all the others will not run because they will just be skipped if the first one skips. So you know that you've got a problem. If you really, really want to run all of them, you're gonna have to put them sequentially, or at least, replace with a tunnel, and I don't know, maybe just index everything like this. Now that's gonna run all the 30 test. Okay, that's the difference. It's completely up to you as a developer what kind of workflow that you want. Now, this is not very useful because obviously this test, we expect that it's going to return, always the same thing. Now, why was it not passing the test, was failing? That's because we were asserting that the response was true, but it's false. So let's see here. In our polymorphic VI, let's assert that it's false. Now all the tests should pass. Okay, not very useful either, because I don't really care if it's 0.1, 0.2, 0.3, 0.4. What I really, really want is that all these tests are asserted. So we have one little feature in Caraya that is assert only. Assert only will essentially not register this assertion with the framework, but just return an error if the assertion is false. So in this case, it's not false. And what we could do is merge all the errors. And if there's still an error, if there are no errors here, then that means that, everything is fine. So we will use the framework here to say that we should assert that there are no errors, right? And here's the design pattern that I'm going to use. Okay, so any downstream error will prevent these tests from running. But if they do run, I want to run them all, merge the errors, and if there are no errors at the output of that loop, that means that I assert that it worked fine. Now, when you don't assert when you only assert and you don't register that assertion with the framework, the label is completely irrelevant. We're going to label the actual assertion that gets registered to the framework. So here, what we should see as a result is 30 iterations that are merged into a single error. There shouldn't be any errors, and it should assert true. So let's run it. Boom. Okay. Now test. Okay. This is the error. This is the node, actually, the assertion that has been registered with the framework, not that one. So we're slightly in a better position now to start iterating on all our tests, but we should probably, define that this is to test the lower interval. Good. So now I'm gonna go very quick because I don't want to bother you with repetitive tasks, okay? Because sometimes unit test is a bit tedious. It can take a while to run. So this is kind of a pattern, all right, that I wanted to show up front. And that's a very, very useful pattern for running things in a loop, okay? You could replace that with a Monte Carlo iterative process to try to find local minima in a function. All right. Now let's go back to everything that I had defined before, right? So these are actually the different tests that we want to do. So I've already done the first one. Let me copy the rest, okay? So this is the extent of everything that I need to do to test this function based on the requirements. Good, coming back here. And because all these don't, well, this node doesn't depend on, anything else. It's by value, and I can totally run them in parallel. So I can parallelize all my tests, which means that LabVIEW will be optimized to run everything as fast as it can. This is the actual interval. So within interval. And I want to have my upper interval. All right, and finally, I want to see that I have a coercion. I will need only 2 more nodes. So what type of assertion should I make here? I want to assert that the values outside of the interval will be coerced to the interval boundary. So there are many ways to do that. You could do, and let's explore 2, okay? So the first one here, expect that it should coerce to 0. So what I can do is say, okay, equals 0. Oops. Replace comparison, equal to 0. Okay, so is that value equal to 0? And that means it should assert true. And that's lower coercion. Upper coercion. So the other way is to use a compare. So it should be equal value, all right? So that value should be equal to 1. There are other values for compare. I'm going to just show it here. So to go through all these different polymorphic instances. So of course, we can compare assert true or false. We can compare, is it equal? Just the value and type. So that would mean that an integer of 1 and a double of 1 would not assert true. The type, if you just want to see that both are floats or both are U8s, and almost equal is really useful for values that have been computed, maybe with some divides or divisions, and so you insert a tolerance. Okay, so I've got all my tests, and we know that a few of them should not work. First off, there's definitely a problem right now that I've just caught. This guy is supposed to assert true because it's in range. Okay, good. We still have three problems. Now, we know we've double checked and our unit tests are fine, so we can report that we have three bugs now to our team of developer. They will have to fix it. We can go and browse directly where it is, but we've got already definitions, which is pretty nice. Okay, good. Before we go and correct those bugs, let's explore the reporting. Okay, we're gonna close that test and come back to our function later to fix our issues. But right now I want to report those bugs, and that could be in a file that is run automatically by your continuous integration server, or you could just want to email that file to the team of developers or put it in your issue tracking system. So, okay, I'm gonna create a file right now. It doesn't really matter, but I'm gonna put it on my desktop. It's right here, so I'm gonna delete that because I want to generate them again. Let's say that I'm starting with a text file, okay, and this is my function, that the test function, okay. So you see it just works the same way. Now, to create a report automatically, you're gonna have first to create a test suite session. Okay, so this test suite, let's go into the palette. We have two nodes. The first one is define test suite, and the second is destroy test suite. The others are really just accessors for timeout. If for some reason you need to play with that, and that's not really relevant right now. So let's skip. Okay, define test suite. That's a polymorphic VI. So there are obviously multiple instances that you can use. Actually, in the default framework, there is a text report and a JUnit report, which is XML extension. So that's really all there is. As you can see, there's the test report optional input. There's also the label that will use the VI title as the default value if it's unwired. Interactive is a flag that you can set to true if you want the UI to show up. So for the test suite, by default here, it's going to be false. And there's verbose, which is by default false as well, a flag that you can toggle to true that will tell instruct the framework to compute a reason why a test has failed. And so, for example, if you have a complex cluster to validate, you might be interested in knowing that the 8th element is the one that failed to pass the test, and not have to worry about, oh yeah, the cluster has failed, so maybe I should go into it, and I don't know. You should probably test all your clustersaurus, but better yet, you might want to not use larger clusters that are difficult to debug. So in this case, verbose will stay off. The reason is it is off by default, you might ask, is that it relies on variant, and drilling into complex data types takes time. So we've decided to leave it false by default, so that if you really don't care about execution time for your test suite, you can toggle that through, and it's going to append to your every test case that you have. And when they failed, it will show you a basic explanation. All right. So let's do that. The test suite is a class, so that's why we have a constructor and a destructor here. All you need to do is, wrap your test VI in between the constructor and the destructor, and that's it. You're good to go. So now, let's say that I want to make sure that this runs exactly as before, I'm going to use Control R, run, boom. You see I still have the same thing. And if I don't show the UI, then, well, nothing happened because I didn't wire the test report. So, okay, let's wire a test report. Well, there are two ways to use a test report. The simple way is to just, take the polymorphic instance and whoop, suddenly I've got a report path. There you go. I run it and, well, guess what? I've got my test suite that ran. There you go. Failed. It tells you which one failed, but you see there are no comments. So I'm going to put the verbose flag to true and run it again. There you go. And suddenly, well, very simple. It expected true, it asserted false. Okay, not very useful for true and false, obviously, but for suddenly, whoops, I had an expected value of 0.8 and I asserted value of 1. So here it is. Coercion didn't work. Now here's something though. It should do the exact opposite. I should assert 0.8 because that's what happened in the test, and the expect 1 and assert 0.8. So it means that I've reversed the output, the inputs to this function. Okay, so the function question was this one. No, actually this one here. So if I were to wire it the opposite way like this, now my report should look exactly what it should. All right, so I expected a value of 1, but I asserted a value of 0.8. Good. Okay, about XML, well, JUnit, boom, that's it. Now, I probably want to change this here, the extension. Now I've got a new file. I'm going to open it with Notepad++ again, and here it is. I've got a failure, and I've got a message, which doesn't exist for all those that passed. Again, expected value 1, asserted value 0.8. I know exactly what was wrong with this. Okay. That is the simplest way. When I know my extension type, I know that I've got the right path, I know everything. So the other way that I could do that is go back to my default one. There you go. Okay. And now in the advanced, well, test reporting, there's an auto select test report, which is basically just a factory pattern. Inside it will check for the extension very simply, and it's going to output a test report that you can wire into the optional test report right there. So if it detects an XML file, it's going to just select the JUnit, and if it's a text file, it's going to automatically select the default text file. So this one will be, let's say I go back to text, I'll delete my file. It's been recreated, and yes, the time has changed, and I still have my upper coercion message. Okay, now I think we're done. Time to go into our function and see if we can fix our issues. So the first issue is that my coercion shouldn't be from this output, but that one. Let's do that with, oh yeah, I fixed my 2 upper and lower coercions, and I'm still with my upper boundary, right? And I know that if I include the upper limit here, I will have fixed my other problem. Let's see, is that true? And yes, it is. Awesome. Last thing, if you forgot to create, or you didn't want to create a test suite, you can definitely output directly here your override directly from the export test report. The reason why you'd like to use the test suite is for automation. If you will do the same test over and over again, if you want to have different reports for different sections of your code, or maybe you know, someone else is creating those reports and wants to get them straight into the continuous integration server. Now, the difference also with the test suite is that you can come up with your own test report. There's a tutorial online for that. If you look on my YouTube page or in the GitHub wiki for Caraya, you should find that tutorial listed there. These two reports here do not handle any extension classes that you might come up with. Okay, so before we finish, I just want to show you last thing. Run all tests. Let's say that okay, I'm gonna just copy this. Why not have it run two in parallel? So whoops. Merging the errors. Bing, bing. All right. So let's pretend we have two tests. Okay. These here will run sequentially because they are non-reentrant. But since Caraya 1.0, for those of you who have used Caraya before, know that if you run two non-reentrant VIs like this in parallel, the test will all be concatenated into a single test case because they have the same name. If I open this, it's called interval testing, and if I open this one, well, of course, it's the same instance, so it's interval testing. Well, starting with Caraya 1.0, we have a new feature that makes each test completely independent, whether they are reentrant or non-reentrant. All right, thank you very much for watching. Stay tuned.